In this demonstration, we'll take a look at how pseudocode maps to real code. What we'll do is we'll use lesson 2 as the guide for that, and I'd like to point out to you the chapter 2 source code. We also have this posting, don't struggle with pseudocode, and what it does is it points back to the source code for each of the chapters. So let's take a look at this one. Now what you do is download this zip file and then unzip it at your desktop, and you'll see all of the chapter 2 programs. And what we'll do now is we'll take a look at only 1, 11, and 14. Now if you right mouse click, and if you have your code blocks linked to CPP files, it'll open up code blocks. As we've seen before, you get a tip of the day. We'll just put that aside for now, and we'll notice that the 3 files that we selected are actually showing up. One of the things we hadn't talked about last time, I don't think, is you can resize these windows, so I'll move this down so we can see it a little bit better. We'll start by selecting program 1, but here's the source code that maps to the program in the book, and I have a copy of it right here. And let's take a look and match this up. But you see the middle here, the things that start with C out, those map directly to these 3 lines that say display. So the pseudocode that they're using in the book is they're staying consistent on it. So anytime they say display, what that maps to is a C out. The other thing is they have this string here, Kate Austin. You see Kate Austin listed next, and then end line. What that does is it's like a carriage return line feed is actually what it is. It's like a typewriter. And then we have another C out, corresponds to display on the next one, 1234 Walnut Street, and here you see 123 Walnut Street. This one has an E on it. We can fix that, easy enough. And then again it ends with an end line. Then finally we have the final line, Asheville, North Carolina, 28899, and you see that over here again. So everything above that is what it takes to run the program. These double slashes are comments, of course. These comments are I've requested on all closing curlies. Here's an opening curly, and there's a closing curly. Main is part of the overhead. The opening and closing curlies are part of the overhead, and the system pause we talked about in the last demonstration of Hello World, and return 0, those are overhead. What you won't see in your downloaded code is this standard lib include here. So if you want to use the debugger, you're going to have to add this line. So let's go ahead and choose build and then build. We see the action down here, and when we get the final process terminated with status 0, it built well, and all we have to do now is run it. And there you go, Kate Austin 1234 and the rest of it. You can take a look in the book. They have an example on the next page showing that exact output, so ours matches exactly. One of the homeworks is similar to this. I'll hit enter a couple times and we'll escape from there. Now the other thing that I want to show you is then that here's our program back where we had the programs all loaded. We have program 2_1. Here was our source code, but now we have an executable file, and we also have this object file for 2_1. Let's go ahead and right mouse click on this, open it up. It should execute just fine. There it is. So you get the same thing. Okay, now let's move on to program number 11. We already have it loaded over here, and let's just talk about how that maps to pseudocode. First of all, we have display. There's a couple of displays as you see them. We've looked at before. That means C out. Well, guess what? Here we have C out, C out, C out, C out. And let's see if that matches up. First one, enter the desired future value. There it is, enter the desired future value, and so on. Enter the annual interest rate. Here it is. How many years will you let the money grow? There's that. And then finally you will need to deposit, and that's listed down here. Okay, now this time we have input. So we're going to input to future value, input to rate, and input to years. Input is done with C in, and we have 3 of those. So here's the future value, here's the rate, and then here are the years. Now, there's a difference that you need to have variables in order to collect those values. So that's what's happening up here. We declare a variable of type double to put the future value, the rate, and the years in. We're also going to create a variable called present value, and we'll see that that'll actually get set down here in line 7. We see a set. A set is when we do assignment. There's a variable called present value here, and then there's a future value with this formula. Let's talk about that. Here's present value. We saw it declared right here. We're using it here. We're actually assigning it the value of this formula here that does a calculation. It takes into account the future value right here, the rate right here, and the years that were input by the user. Now we have one extra special thing here. In order to make this formula work, we are using the power function. We'll talk about functions in a couple of lessons, but right now just use this thing as is. But what it basically says is take the rate plus 1 to the power, or raise it to the power of the years, like here. 1 plus the rate to the raised to the power of years. And in order to do that function, we have to include a new library. This is the C math library, and we've seen these other includes before. Let me point out a couple of other things. Opening, closing curlies. We want to start to really worry about indentation. The curlies should line up vertically here, and then everything between that 2 curlies should be indented, at least 2 spaces. If we introduce another set of curlies here, which we will be doing shortly, you'd indent again 2 more spaces. So one of the things that ends up in your grade is indentation, if it's properly done. So let's go ahead and compile this thing and see how it works. So let's build it as we've done before. Build, and we're watching it. Compiles okay. We could take a look at the output, but we'll just go ahead and run it because we've seen that kind of thing before. Okay, so we run it. First question it asks is enter the desired future value, just like we have in the sample output. So it's 10,000. Enter the annual interest rate. It's 0.05. How many years? 10 years. And it should calculate, and we get the same number. Now we're actually getting a decimal value, whereas this is just showing us the integer part. This is acceptable. That's fine. If somebody took my 13 cents, I think I'd be upset. So I would want to hang on to it. Okay, so enough of that one. Let's move on to example 14 in the next demonstration. Bye-bye.